It was great. I really liked the simplicity of it all. Ease of use was great, and I think it monitors the key actions that can affect myelopathy, like walking, holding objects, and the dexterity. Hello and welcome to Myelopathy Matters, the official podcast for the charity Myelopathy.org.
Where we talk all things degenerative cervical myelopathy from the perspective of the professionals, the researchers and the people living with myelopathy.
I'm Ewan Sadler, a person with DCM and a founder of Myelopathy.org.
And I'm Ben Davies, neurosurgeon scientist and also a founder of Myelopathy.org.
This is Myelopathy Matters by Myelopathy.org.
So today we're talking about MoveMed, a very personal project for me and one that I'm really delighted now to be sharing with you, the myelopathy community. This is a solution which aims to help diagnosis of myelopathy, but also more accurately monitor the condition remotely, empowering the person with the condition to really take charge.
I think this was the first time I met you, Ben, when we were looking for volunteers to test a prototype. Was it 6 years ago now? So I'm really looking forward to hearing more about this project.
Well, it certainly has taken some time. I think it must be about 6 years. And I guess it's over to you today, Ewan. I'm putting my guest shoes on today and handing over the podcast reins to you. Should I feel worried?
No, not at all. When has an Englishman ever had anything to worry about when his fate rests in the hands of a Welshman, apart from the rugby? But we won't go there.
Well, I have brought my colleague Alvaros, our Chief Scientific Officer for the MoveMed platform, for support. He's a former neuroscience fellow from NYU Abu Dhabi and a budding clinician who codes as a student doctor at the University of Manchester.
Hi guys. So Ben, the first question is for you. How did the idea for MoveMed first come about? What was the problem that you were trying to solve?
We first started to look at this really with myself and Mark Cotter, and it must be, as you say, 7 years ago now. And I think the starting point was we were designing Mark's regenerative medicine trial called Recede Myelopathy, which you can hear more about in next month's podcast episode. But the challenge we were initially looking at is that essentially trying to detect a regenerative signal in functional recovery is really difficult. The measurements that we have in myelopathy aren't very good. We know that surgery has quite a big uplift on those scales anyway. So trying to detect that additional benefit of a drug was a big challenge for us. And, we didn't really have anything that was particularly sensitive or responsive. And as we got more into this and tried to look at all sorts of different options, we also then started to design this trial with lots of different types of measurement in it. And then the challenge with that and delivering that is that people get bored of doing lots of different assessments. And you have this big issue in clinical trials of missing data. And if there's data missing, then the credibility of the trial's down. You can't really evaluate your scientific ideas. So that was probably where it sort of started. But then, what really captured my attention in this condition of degenerative cervical myelopathy, particularly sitting as a surgeon, was the frustration that actually surgery can be incredibly effective if we give it at the right time. And there was that challenge of being able to make the decision for the individual that this is the right time for your surgery. And that was partly because there was such incredible diagnostic delay, but also even when people did come into clinics at an earlier stage, again, it was that issue that we didn't really have the tools at our disposal to really make that judgment on a really objective level. And I think one of the challenges that we have in a condition like myelopathy is that we really haven't got blood tests or imaging that can offer that sort of specific marker of the condition. We're really reliant on looking at the individual, asking the questions, seeing how they move. And that subjectivity is an issue. And I think it becomes less of an issue if you really come into contact with real experts. But we recognize that the awareness of this condition is poor. And also the confidence of making neurological examinations and diagnoses among non-specialist doctors is also very low. So if you consider them to be the front line of professionals that you might meet when you first have symptoms, that issue of how do we make all those other doctors more expert in picking myelopathy up is a real challenge. And perhaps if we could find a way to take it out of their hands, then we might have some more success. So those, I guess, were the sort of raw sort of drivers. And then, when we started to look at how we might solve the problem, well, I think we were obviously very aware of the buzzing concept of technology and wearables. I guess it's sort of my interest and background to some degree. And, we were also aware that, the data coming out of those devices is incredibly noisy. You can imagine trying to monitor a sensor all the time, not really knowing exactly what an individual's doing. You get a very, very noisy signal. And, I think this has come through very accurately. As just an example, if you look at the Apple Watch, which is probably one of the sort of more sophisticated devices out there, one of their big sort of healthcare flagship pieces of work was this ability to detect atrial fibrillation and a funny rhythm of the heart. And in their landmark study, they were only accurate 1 in 3 times, and they missed true cases in 3,000 patients. So it really shows you that actually the signals coming out of these devices are incredibly noisy, and them alone might not be the solution here. And I guess in parallel, what's evolved a lot in clinical practice has been the shift from sort of paper questionnaires to what's called a computer-assisted technology testing, where you sort of do interactive tasks on screens. And I guess that sort of opportunity and synergy and recognition of those sorts of ideas was probably how we started to recognize that was the problem. These sorts of technologies are out there. How can we sort of work something out that can sort of target all of those needs based on those drivers and bring something that's useful together?
Yeah, I totally agree with you there. So how did you first turn this idea into a real life product?
Well, I guess, a lot of this comes down to timing and opportunity, doesn't it? I sort of, we were struck with this conversation. I can't even remember how it started with me and Mark, probably some sort of sporadic conversation, which built a bit of momentum. And then I was sort of looking at the university at Cambridge, which is obviously full of incredible people, and sort of searching for somebody who might provide the sort of expertise on a technology side. And we happened to come across a chap called Robert Hall. His sort of thing was wearable sensor technology. And I think actually his PhD he basically built some sensors to wear. He's a really keen athlete. He likes running. I think he's a track runner, maybe 400 meters. And he was trying to, I think, analyze his running style to make him a better runner. But he brought that experience in terms of A, the technology, and B, that sort of data and et cetera. And it sort of grew from there. And I think we built that first prototype, which in essence was something that combined a bit of background monitoring, but also some very specific tests that we as doctors had thought might be relevant to myelopathy. And put those together, and that's I think how we first met you, wasn't it? We asked for a few people to come and test it out in a sort of lab setting up in Cambridge.
Yeah, I remember it well, especially the 5-hour drive down there as well. I think my neck's still aching from that. So what does the app actually look like?
Well, it's quite simple, really. I mean, you load the app and essentially you see a list of different types of tests. And these we call interactive tests. And essentially, one of them is tapping a target on the screen as fast as you can in 6 seconds. One of them is doing a short get up and go. So you sit down, stand up, and then walk. And the other one at the moment is around keeping one arm steady for, again, I think it's 10 seconds. So very short tests that we ask you to do quite interactively. But in the back of that, there is a lot of data being acquired through general activity use, much like watches do for sports and things. So that's sort of what it looks like. And I think it's that ability to have the combination of the background monitoring with those very specific, what I call high fidelity readouts on the disease, and those interactive tasks coming together that gets a very comprehensive picture of the condition.
So what did the first stage of testing actually show you then?
It basically confirmed our sort of concept really had some promise. We had these tests, and I think the readout from those sensors, even in a small group, was really accurate. It was very much correlating with what we would expect the normal scales to do. And, we had a few different insights that we hadn't even seen before. So one of the things I thought was very interesting was that we saw that even in a sort of 6-second tap test, so you tap a target for as many times as you can, we actually saw a decay in performance amongst the people with myelopathy that we didn't see in healthy age-matched controls. And I think it's a sort of new insight. We're not really aware of that, but I guess it aligns perhaps with some of the experiences you talk about me. But I think for me anyway, it's like the idea that if you push someone with myelopathy, it sort of exposes more of the difficulties they face. And I think we could start to see that. And it was a very interesting signal to both distinguish healthy from non-healthy, but also as a measure of how bad the myelopathy was.
Yeah, well, it seems such a long time ago now. Did this all get forgotten about? I know things like this do take time. And what has taken you so much time to develop this app?
What a great question. I mean, if I knew what I knew now, then it wouldn't have taken so long. But I think the principal issue was we were really struggled at the first stage to find the funding to get it off the ground. You know, everything that we'd done up to the point that we met you and had been done sort of in our free time. And I think Mark's had a lot of other things going on. Everyone was becoming busier. Rob's now a professor, so there was just less and less time. And I think one of the real game changers was the decision to stop trying to pursue this as a really academic project and try and think about whether we could secure alternative sources of funding, i.e., commercial investment, and make it a technology which has got a really commercial opportunity. And I think, it's not to take it away that this is something that doesn't have the aspirations of changing care, but it's just a different route of trying to get the thing developed. And that has been a much more successful journey in the last couple of years, including the opportunity to meet Alvaro.
Yeah, and we've kept him on the side for so long, yeah? And I guess, Alvaro, this is where you come into the story. How did you meet Ben, and why did you become interested in developing MoveMed?
Well, I think my story with Ben is one of serendipity, really. I was coming out of my fellowship in NYU Abu Dhabi, and I was set to train in medicine in Manchester. This was at the end of 2020 now. And I was looking for a mentor in neurosurgery. So I took on LinkedIn and sent a bunch of messages to people that were working in neurosurgery in the UK, trying to find this mentor. And Ben got back to me, and that's when we started having a conversation about what a career in academic neurosurgery looked like in the UK. And I was really fascinated by it, including the opportunity to work with emerging technologies at the very forefront of this field of specialty. So as we continue to speak, he challenged me to work on this small project within the Recode DCM project, which is described previously in this podcast. And my task here was essentially to review all the questionnaires and surveys that had been used in DCM to assess various aspects of the condition. Surveys looking at neck pain, surveys looking at finger dexterity, surveys looking at gait and walking. And as a part of that project, I learned a few important things. First, how important objectivity is over subjectivity in medical assessment. Subjectivity does bring a very important quality of information to the table, but objectivity cannot be compromised on the way to obtaining that quality of information. That is to say that it's not the same to see a hand tremble and add the length of seconds that hand is trembling or the vigor with which that hand is trembling. It's not the same to do that than to simply ask, how do you think your hand is trembling, right? It adds important data points to the patient's journey as well as to the diagnosis. And that is not something that I think we are doing enough of in medicine. And so when the opportunity came to participate with MoveMed, I was really excited to take it on. I think I brought this sense of urgency on my end to participate in what I think is a data revolution. Elsewhere in the world right now, there is a revolution going on, the data revolution. And the great news for medicine is that fundamentally, medicine is a data science. And so we're at this important crossroads where we are evaluating how data science approaches can revolutionize our understanding of conditions, both rare conditions as well as more common ones, with the power of numbers, with the power of assessments, and with the power of the mobile phone, which just decades ago, we didn't even dream that people would carry these devices that can quantify and can tell you how much a finger is moving, or that can prompt patients how severe their symptoms are today. And coupling that with modern medical understanding was something that I did not want to miss out on.
I remember when Alvaro reached out to me, it was just I almost didn't reply to the message because you get a lot of random messages through LinkedIn, to be honest. But he tweaked my interest because I'd been to the University of Manchester. So there was some sort of, nostalgia. But I'm not a very good individual at judging an individual at the beginning. So I guess I'm very wary of, judging a book by its cover, for example. So when people approach me wanting to sort of do research, I tend to set them really difficult for upfront tasks, really boring, quite logistical things that I don't really have to be too close to, but they're almost like a sort of test for them. If they come through that, then they're worth spending more time with. And I set Alvaro the most almighty challenge. You can just imagine trying to look at all the different assessments in use in DCM. What a tall order that was. And then he turned this piece of work round in such high quality. I have no idea what I would have done if I hadn't found him. And been an enormous part of supporting the recode in terms of delivering on its minimum data set. So, that I guess was a sort of light up bulb moment for me, thinking, this is somebody who could really help kick forward this project that's been sort of struggling for so long. And as he mentions, his interest in data and all those fascinations have been a really incredible partnership, I guess, and really kicked us forward in the last 2 years.
I've got to agree that when I first met Alvaro on our first Zoom meeting, the enthusiasm actually came through. So back to Alvaro now, what sort of skills do you think that you bring to the MoveMed team?
Well, through my neuroscience background, back when I was doing my fellowship, I got really interested in data science approaches, which is to say, grabbing huge Excel sheets and taking on the challenge of turning the numbers embedded in those sheets into insights, into conclusions, or into ideas that you can then take on to develop and iterate. Originally, I was working on big data sets from genetic expression in the brain, as well as data on sleep and electroencephalography. And the methodologies that I learned as a part of those experiments, I brought into MoveMed, not in the sense of analyzing brain waves, but in the sense of taking those numbers from assessments, from the tasks that Ben was describing you can do through your phone, and getting those insights, getting those conclusions, getting those signals about how heavy that hand is trembling, or how dexterous that finger is performing, or how, for example, does a good day look like when a person living with DCM is walking, or what a bad day looks like. And I think that's something that really drove me forward, because it means that we can understand the patient beyond just the day of the appointment, which often they wait so long to attend, but the symptoms don't always manifest on that day. And so to have the ability to extract these insights when the patient wants to take on a task using their mobile phone and then relay it remotely to their attending doctor, I think that's something that's really important that I wanted to bring to the table.
I think it's absolutely awesome. Yeah, and you've highlighted, the main points there as well is, the symptoms aren't there every day. And when you go into the doctors, the symptoms that you had the day before may not have them on the day of that appointment either. I'm going back to Recode now because you've both been involved with the Recode. I'm going to ask this question to Ben. Did Recode sort of offer you, Ben, any useful insights?
To be honest, it's sort of really changed my whole view on things. It's kind of created a direction, really, I think, with MoveMed as well. And I think the central point, which we're sort of highlighting throughout this, is that you need to really understand the people that you're trying to help and to listen to their experiences, because what we've seen in myelopathy is that myelopathy has been looked at very much through the lens of a few individuals, really professionals, and it's sort of totally missed a whole part of the condition which is there. It just hasn't really been looked at. And I think it's really shown, by talking to people with myelopathy, the good day, bad day phenomena, for example, the idea of being pushed and that having that sort of hit back the day after, the fact this is really a whole body experience. And I think, therefore, trying to capture all of that is all about trying to really establish some measures which can really mark this disease and also separate this disease from other conditions. I think one of the other things that's seen through Recode is that there is a real role for patterns, and I better explain this a little bit better. But one of the difficulties with tests is that you have to bear in mind that everyone's different. and there's going to be variation, natural variation. Even if two people have got a sort of similar level of myelopathy, their experience can be very different. So how do you account for that natural variation in what you're trying to measure? And I think that comes from trying to look at the individual more, as opposed to trying to compare them to somebody else. And I think with myelopathy, there's a great opportunity because you can, compare the right side of the body versus the left side of the body. You can compare yesterday to today. And those sort of internal controls, that I call them, means I think that we can reduce a lot of the noise that we'd otherwise be picked up trying to compare, you into somebody else. And that's, really a game change in terms of the way medical medicine is looked at. Because at the moment, most tests in medicine revolve around testing, a patient against somebody that's normal. And not everyone's going to fit into those ranges. And I think that moving away from that is really important. And the final part, I think, which Alvaro again has touched on, and I think it's more than just trying to glean insights from data. It's really trying to assign value to them. So I think there's an explosion in data science now, and we're getting many more data-driven perspectives on conditions, including myelopathy. But ultimately, unless that data delivers something that you can do, does it change your medical care action? Do I offer a treatment? Do I offer a scan? Do I do something different? Then ultimately, that number is meaningless. And I think it's that critical issue here about trying to take the data and generate something that changes behavior that is the key further gap that a lot of this technology is not even thinking about. And I think that insight, that recognition really came through from working and listening to people throughout the RECODE process.
Oh, that's awesome. Alvaro, I understand you're now retraining as a medical student, and as a person with DCM, I've got to ask you this question. Has your teaching as a medical student ever taught you about myelopathy?
Sadly, no, Ewan. I will caution that I am still in my second year, so I've not finished all of my medical training just yet. But you're getting to a point here which is really important, which is how little we are taught in medical school about conditions like myelopathy. And I think this is really important because tangentially, when I have been telling some of my South American friends and some of my relatives about what it is that I do with RECODE and with MoveMed, and I tell them about DCM, they often recognize the symptomatology, and many have not been able to put a name to this pattern of things they feel or experience, which is why I think it's really important that we do more to teach about myelopathy and to raise awareness about myelopathy. And it just highlights how timely and relevant projects like RECODE and this podcast really are.
So what are the main ambitions for this technology then?
Well, so first and foremost, like Ben mentioned, there is a huge potential for technologies that can be accessed through your phone or through other technological wearables to be used in monitoring the condition. We've spoken about ways in which you can capture the missing bits of disease that don't really present the day of the appointment. And in that sense, monitoring for those signs and symptoms through things like clinical trials is really important. So we can access that information and eventually down the pipeline create treatments for it, improve surgeries with this information, and perhaps come up with better medicines for these conditions.
I think what people cannot appreciate is that essentially when you design a clinical trial, you design the trial to make sure that you can confidently conclude, yes or no to your hypothesis. And so what I mean by that is, let's say you've got a drug trial and you want to prove that the drug is beneficial. Then essentially you design the trial to be sure that the difference between the two groups of patients, so the ones who get the drug, the ones who don't, is definitely down to drug, not down to chance. And the problem with current assessments is that the difference between those two groups that you're trying to measure, because they're so rubbish as tests, is quite small. And that means there's always a high chance that could simply be a chance result. And therefore, what you have to do with your trials is have hundreds of patients in them in order to prove for certain that it's the drug and not simply a coincidence. And the problem with that is it incredibly drives up the costs of these things. And obviously trials are risky. You don't know that the drug's going to work. So they're a big undertaking. And because of those massive costs, they're acting as a huge barrier to the explosion in medical discovery. Because really, on a commercial level anyway, by the time you're trying to prove a drug works, you're pretty much beholden to the big pharma coming in and supporting you, because they're the only ones with the capital and the appetite for that risk to be able to take this on. So, all of the science coming out of universities, the early startups, they can't really get a foothold in this unless they have that backing, and it's a complete bottleneck. And I think it's holding back science.
Yeah, I'm surprised how long the research actually takes.
Mm-hmm. And it's not just trials, Ewan, that where we see this technology having a really positive impact. It's also in the supporting of decision making, which takes place after a technology is adopted, after it's gone through all of these rounds of research and testing. Ben can perhaps comment more about this, but in clinical practice, we've identified at least two important use cases for technologies like this, which is in helping come up with treatment options that are personalized to patients, or perhaps in revising treatment options that are no longer fit for the current level of disease, and having a means of relaying information to your doctor through a mobile phone wherever you are, whenever you are, is, I think, really important in making sure that we personalize decisions to people as much as we can. And today we can, and therefore we must.
I think that's really important. I think that's certainly a near-term opportunity. I think the other one, of course, is trying to help the diagnostic process, because we talked a little bit about the difficulties in triaging this condition. I think on average now, these problems in myelopathy are not unique to myelopathy. It is a neurological condition wide. I think the average number of doctor consultations before a diagnosis for a neurological condition is almost 5. And so if you can help add a layer of information on there that can help pick the right diagnosis earlier, then you can access treatment earlier. And ultimately, a lot of neurological treatment is more effective if it's given earlier. So I think there's a case there, both in the sort of optimization of treatment, but also the pickup, which is a critical issue. And just to extend that concept, the way technology is going now in healthcare, we're moving to an era now what we call digital therapeutics, and this is going to be a phase where essentially not just a drug, but you'll be prescribed medical applications. And I think there's going to be an opportunity that you have your app for myelopathy, for example, and it's got such a good readout of your own condition, it can really personalize your own healthcare journey. It might be, for example, in Parkinson's disease, altering the timing of your treatment, all this kind of stuff. But it comes down to adding that additional benefit, as Alvaros mentioned, of personalizing the care, rather than considering that everyone is just the same as the person next to them.
It's amazing, absolutely amazing. I can't agree more. We need to reduce the time from diagnosis to treatment. And I'm presuming it's more than just the two of you working on this.
It is, absolutely. I mean, it started with me, Mark, and Rob. It became another gentleman called Anthony, who's a software engineer, and then we met Alvaro, and more recently a chap called Nick's come in, and also a chap called Misha, who's another sort of bioinformatician. So that's the sort of stronghold, and we're hoping now to build further, because it's got great potential. It's been limited so far, I think, by individual bandwidth, and we're bringing in the sort of diverse expertise to really scale this up and hopefully seize the opportunity.
So I can see the app is now available in the Android and Apple app stores. So what have been the developments since you arrived, Alvaro?
Well, very exciting developments, really. Since I arrived, I think one of the most impactful things we've done is to lead a small testing phase with people living with DCM that was wrapped up last year. And one of the main outcomes from this testing phase was the ability to tease out signals, the ability to see a hand tremble through the mobile phone tasks, the ability to tease out what a good walking day is and what a bad walking day is. And of course, what really excites us here is the ability to turn these signals into information bits that the doctor can then incorporate in the diagnostic process and in the treatment decision-making process. Another thing that was really important that came out from this testing phase was that folks living with DCM told us they wanted to see how they were doing at the end of each of our tasks. So I'll demonstrate with an example. One of our tasks involves tapping really fast a target on the center of this screen. And people were interested in seeing how many taps they had accomplished. Another of our tasks is holding the phone with your arm outstretched to see how stable that arm is. and people wanted to know how stable it was. So this year we've worked on adding a metric that can tell folks how fast they are tapping that target and how stable that arm is.
It's critical here because people get bored of the test, you lose the data. So you've got to make that test interesting and rewarding. And I think, again, it comes back to listening to the person using it. And we're sort of talking about it as gamification, the way we can make it hopefully a pleasurable experience to do these tests and still capture the meaningful insights.
Yes, absolutely. And one last important thing that came out of the work of this year is that doctors asked us for a way to visualize the results of patients performing these tasks. And so what we're doing at the moment is enhance a way of putting this information on a portal so that not only patients can take a look at their performance at the end of the task, but also so that doctors can see how the performance of these tasks is evolving over time. I think there's great interest from both patients and doctors to see if the patient is improving over time or if the patient is worsening with time. And the ability to have tasks that relay this information facilitates a way to visualize this progression.
I mean, you were part of the testing, very kindly, I should add. What was your experience?
Yeah, it was great. I really liked the simplicity of it all. Ease of use is great, and I think it monitors the key actions that can affect myelopathy, like you walking, holding objects, and the dexterity. It would also be great if there was a pain monitor added to it in the future. But all in all, I thought it's a great app, and now knowing more about it, I think it's a step forward in the right direction, really. So, how does this technology differ from, say, the other things you see in the news, like Apple smartwatches, etc.?
Well, we're trying to take, I guess, a keen eye on the problem we're trying to solve to sort of make use of lots of different technology that's coming about at the same time. So I think the key things are we're trying to make a solution here which is not relying on you having one device over another, not having an expensive Apple Watch, for example. We've tried to bring in some of this specific information in these sort of interactive tasks that gives a much higher readout on the condition than just simply trying to interrogate this very noisy background data. And that combination, I think, is a real unique opportunity here. As I mentioned, we've learned from the fact that we really need to make these tasks a pleasurable experience if we're going to get people engaged and not just using it. And I think that means that being able to see their own data and see those results and see how they're getting on. And I think the other thing in the experience, I guess, is that from our very clinical orientated thing, particularly with the recode, is that, as I said, you can't just generate data. You've got to generate meaning. And I think that's where we have a unique opportunity and an angle that makes us very different from everything else that's out there.
Yeah, and I think it's great for the end user to actually see that data as well. That'd be brilliant. So, what are the next steps for developing the application?
Well, right now, we got a working technology that is available on the Android and Apple App Store, as you mentioned, Ilwan. But this technology needs to be tested by the community that it is designed for. So therefore, in the next months and years, what you will see is we will be needing to assess this technology and test it through clinical trials. And on the road to getting to those clinical trials, it is absolutely essential to count with the involvement of folks living with DCM so that we can not only capture their signs and symptoms and design an application that is suited to their needs, but also so that their voices are incorporated in the diagnostic and treatment decision-making process.
And so I think it's critical that there's two elements here. There's still a piece of learning about, what the data means, a piece around, as you mentioned, the pain that you're adding things in that are missing. But the other thing around this technology is seen as a medical device, much like a hardware implant is, and it has to go through high levels of regulation to be able to be unleashed, essentially. And there's a journey there that we're working through, and it doesn't come overnight, sadly.
Right. We're going to ask you this question. So, how can the DCM community access all this?
Well, at the moment, we're delighted that the charity has agreed to partner on a study. So anyone now with the condition can sign up and test the app longitudinally. We're going to be in contact with you over a sort of 12-week period to see how you're getting on, ask for feedback. And, we want to really hear your thoughts. We want to sort of collect a bit of data, understand you, but what do you think of it? How can it improve? And And I think that would be the first thing. I think to get involved with that, you can either look at the website, Myelopathy.org, and the research page sections, or you can visit the platform's direct web link at MoveMed.io. Or if you're getting lost, get in touch with me or you, and we'll point you in the right direction.
Thank you. I think everybody's looking forward to downloading MoveMed and giving it a go.
Well, Ewan, what were your thoughts hearing all of that?
I thought it was a great insight. The more tools you have to monitor myelopathy, the better. And we know how difficult it is. As I mentioned in the previous blog earlier on, the symptoms can be really sporadic. And most of the time when you finally have your doctor's appointment, the symptoms that you initially made the appointment for has disappeared. So this is a great tool to record the days when a person is symptomatic and having a bad myelopathy day.
Well, we really do hope so, but it's going to be more hard work, and we're really looking for partners and help. If you're somebody with myelopathy and you're available to test the app, please do visit the website and give it a go. And if you're a healthcare professional and you want to roll that out in your clinical setting, again, please just get in touch. This is something that needs participation to really, I think, deliver the benefits. So what's up next month? Well, we are turning to that aforementioned regenerative medicine trial. We're joined by Dr. Mark Cotter, of course, one of the founders of Myelopathy.org, but also Dr. Matt Suda, Chief Medical Officer from Medicinova, about the first regenerative medicine trial in DCM, Recede Myelopathy, now open and recruiting in Cambridge. Thanks so much to Alvaro Yanez for joining us. This was Myelopathy Matters from Myelopathy.org. The podcast was produced by Carl Homer from Cambridge TV. To keep up to date with the latest in the field of degenerative cervical myelopathy, why not subscribe on your favourite podcast app, where you'll also find all of our previous episodes. There's also lots more information to be found at myelopathy.org. But if you've got a question about the condition or an experience to share, we'd love to hear it. Please get in touch at ben@myelopathy.org. But until next time, goodbye.